Hello there. So those of you who watched the road trip to near Grimsby will know what someone we've known for some years has kindly passed on some radios for us to hopefully sort out and raise funds for the GB3GR repeater ongoing things. So at the face of it, it's a very nice looking Mustang CB3000. These use a SINAD 002F chassis, just like the 1000 and the 2000. You get quite a wide set. It's not the normal kind of footprint for radios. You don't gain much. You gain RF gain, you gain tone, and you get, God, that's stiff, and you get delta tune for whatever reason people would put delta tune on. So it's had the power pocket, even the power socket killed. Mind you, at least this is real mains lead, not like that socket board we were playing with. I'm going to have to print myself off a sheet. This has been messed with something chronic. What's that switch? Well, that's speaker. Ballast resistor missing. Just look at that crystal filter. Oh look, we put a crystal filter. We put it on a stalk. I'll put the soldering iron on. I better print off her job sheet. Okay, that's printed that off. We'll just do some obvious things right away. Right, we'll get rid of this gas poker fitted filter. And what is it? Oh, it's some kind of filter, alright, but I don't recognise it. So we need to sort out the fact they've taken the ballast resistor out, and of course the danger there is that the output transistor will be destroyed. Well, if they had it transmitting, that is. We see it's been replaced, and the other danger there is fakery. Right, that's taken that out. I want to recover the sleeving off that. So you're moving a bit of excess solder there. And now we've got a very, very scrap SINAD 002F, exactly the same model as this, and it's just possible that our very scrap one may have enough parts on it for us to see the secrets. That is corrosion. So we'll go over that with the chemical cleaner. I'll just reduce this. Obviously we're going to sort this power lead out, but for now I'll just make this a more manageable length. Because there's a possibility we can't recover the radio, you know, it can happen. About 2%. So unlike that socket board, this 2-core mains lead is 3-core. I'll just chop that out so we don't get confused. It's got more meat on this than that fake power lead the power board had. Okay, well, it's had some transistor bolted down there, or not. It's been somebody's play toy, hasn't it, this? What a shame. It always managed to top of the range radios. Now I'm hoping that we can find, that's Royal We, our very much smashed up one of these. Well, we've got an Amstrad genuine one, in case that's all we find. I'll just go in my shed. There we go, I've got it. I thought this is a radio rally. They thought, I mean, look how stupid. Variable power. All they've done is connect it instead of the power preset, which is the meter. So all it does is, when there was a meter on this, it didn't come with a meter, all it would have done is varied your TX on the meter, not in reality. But there's a possibility that transistor, because the ballast resistor is still in place, there's a possibility that if we need an output transistor, we can recover it off this. Yeah, that's the original. And that's the original driver transistor too. So that's really good. I will just tell you, I paid 10 quid for this scrap chassis. I know we've had a few bits off it, but we didn't have a front. But I thought, oh, Mustang 3000. Want. So now, you see, we can look at the bottom of this, and we can see the difference. We can have a look at the bottom of this. And you can see that we've got these 3 capacitors here. We've got the resistor there, but we haven't got the electrolytic, and we haven't got the extra capacitor in the phase lock loop department. That might be compensating for a Duff crystal. Well, let's get rid of those. And that's why we buy this stuff. Although we've got the service manual for the Amstrad, and we're supposed to have the service manual for the Fidelity 2001, the same chassis, Mustang never did any service manuals. I did write to them. I said, nope. Was it Langrex and Co? Something like that? Who were the importers? Lautex and Co Limited. I think the thing to do then is to go over this board with isopropyl alcohol because of the gas poker soldering that's previously been taking place. Let's try and tidy up where it's obvious. So we've got a short circuit here on the phase lock loop. Well, it looks that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. No. But it is it? I can't see a gap. We seem to have got a break there. So as I say, we'll be going over this with isopropyl alcohol sooner rather than later. While we've got a link, there's no reason not to have that link. It's just the earth pad. That's a potential dry joint. We'll let them have that link. Should that be linked? It's just got a Mr. Blobby solder, hasn't it? think we've got one of those people who thinks, oh, there should be a part there. Oh, what they've done, they've cut the track for an unknown reason, then they've bridged that track. So we do need to reinstate that. We've got some thin wire. I don't want to have a Mr. Blobby. Okay, so I'll go and get the isopropyl alcohol. I'll finish it off Mr. Chippy's bench, you'd expect that. Notice we haven't powered this up yet. So, I'll get a ballast resistor out of stock, we'll do that now. I think they're these ones. No, they're the alternative. Oh, we've got one left after this. That first pack is a slightly lower value, just in case we're struggling to get 4 watts. I can go a little bit lower in case that happens. Try and keep it around 3 ohms. So that came out. Recover the sister flex sleeving. I know the donor of this radio would like to see it working. I think last time we sold a fully serviced working Mustang 3000 on eBay, I got $39.95 for it with a new microphone and all the service work. I think I lost, I think it actually cost £60 in service work, and that's only at minimum wage and the parts we used. Obviously people don't think as much of these as I do. So we don't know about that transistor. I could measure it, I could take it out and measure it. We'll see what kind of RF output it's doing first. The key here is when you get a transistor tester like we use those Peak ones, like the Peak Atlas here, if you've got massive gain, you know, like 200, it isn't an RF transistor. If you've got a bit of gain, like somewhere between 20 and 60, then it probably is a RF transistor. So one of the areas I've got here is that corrosion. We're going to have channel change problems with that. Right, so that's got to dry, but we can just see some dry joints, potential dry joints. There may not be dry joints. What we've revealed, of course, the first one is there, which I'm not sure that's the one I spotted. Well, that was absolutely disconnected, and that isn't far off. These aren't sets that suffer from dry joints. A lot of this is finger trouble. Right, we need to reinstate that cut there. We'll bring a bit of scrap wire back. Okay, so where's the filter go? Ceramic filter would go there if it wasn't missing from this radio. Oh, well, they haven't taken out the ceramic filter. Okay. Right. So what shenanigans was round here? You don't think they put the filter in parallel, do you? Well, what can I say? Proof of the pudding's going to be in the eating, and we'll power it up. Uses the earlier LC7136. It's had a lot of soldering to that. I wonder if somebody's tried to do an illegal 80 channel mod and then reversed it back. I don't know. And then the other thing is, what's this switch about? Is there a switch on the radio that's disconnected? Yes, there is. So the CBPA switch, I think, has become that. Right. So that needs rewiring onto the real switch. Right, folks, we'll power it up. Keep the power lead on this bench for when, if we get this to work, we can use a proper power lead. I'm not going to fit a new socket until this is working, otherwise I've just wasted my time and money, haven't I? The only part we've put in is that ballast resistor, and that's easily recoverable with full length leads. So this may still be too wet to work. This stuff does dry pretty promptly, but we'll see what happens. Power it up. There we go, we're powered up. We have a dead short. Is that my crocodile clip leads, which I love shorting out? Let's go again. Right, we'll go put that into the speaker. Connect the test equipment to the aerial socket. Switch picture in picture on. And we do have transmit. And it's doing, oh, what's it doing? 750 milliwatts. And we've got smoke coming from somewhere. Is this in the right position? Ah. Better. 3 watts. So I don't think we've got a fake transistor. So we were in low power. That's a bit sticky. I think that's a case of WD-40 rather than switch cleaner, and then we'll chase it out with. I'll just try the service on. The other thing is, without the ballast resistor, it may have been doing doolally power on another band. Well, that seems to be enough to cure it. Okay, I'll take some readings, then we'll write those down. So at the moment it is doing 150 milliwatts on low power. High power, it's doing 3.1 watts. Channel 40 is doing 2.9. Channel 1, let's guess, 3.2, 3.15. Back to channel 20. Current consumption is 1.555, which is quite high for that output. For what it's worth on this test set, we'll just do deviation. Wallow, we don't have any transmitted audio. Let's just see what our walkie-talkie has to say. I'm just making sure if we've got a mic game, we haven't. Testing 1 2, testing 1 2. We have got deviation. I'm just wondering if our meter's been on another band. 1 2 1 2. Wallow, wallow. It's 4. Frequency 2779123. I mean, yeah. Test gear's still warming up, so it'll probably actually want turning down. But that's absolutely brilliant. VCO. Let's do the VCO. It's done on channel 1 on these radios. I need a I need a one of those. I'll borrow it from the thingy meter. We'll stick it on there. So why can't I see the capacitor we need to check? Is it that one? Yeah. So we want about 2 volts on transmit and receive. It's 1.89. Channel 40. Somewhere around 3.5 to 4.5. So on receive we've got 3.3, 3.2. No need to change either of those. If we hadn't got the lower voltage around 2 volts, then we'd need to, on receive, adjust that coil, and on transmit, adjust that trimmer. So that's what something we're not going to touch. I'll do the transmitter and then we'll start on looking at the receiver. I take it we've got no PA, to be something wrong with the wiring on that. Get that out of the way. Frequency's the coil here, and it turns upwards, anti-clockwise, to increase the frequency. And by the time, because these are now 40 years old, some of these crystals have dropped out of spec, so you can't get the adjustment you want, which is a problem. Got to change the crystal, which isn't easy to come across one that works, unless you order them new for £35. No idea where my favourite trimming tool is, so we won't use my favourite trimming tool, and we'll use this one. So we're on the, just need to make sure we're on channel 20, don't we? So we're adjusting for the centre of the peak. Which is there. Centre of the peak. That was spot on. Centre of the peak. It's there. Centre of the peak. Is there. .2. I wonder if some of these coils have got mashed up a bit. That's a burnt looking part. Or is that just thermal compound? Perhaps on t-shirt. Placement of these is so critical. How hot it's been transmitting for a minute, and we're at 3.7 watts. So that's okay. We've changed the ballast resistor, and this is on our test meter, which is selective. So put this on a normal power meter, it's probably doing 7. But the important things on our kind of power meter is what the government would be, an inspector would be checking it with. Bird through line, bird 43 with the correct element, it gives us similar kind of results because they are selective. So I want to come back to this when it's cooled down a bit, because it's a bit unfair to when it's that hot. I think what we'll just do, we'll just put this on the test meter behind me and see what the deviation really is. Right, here goes. Well, it's 4.5. I wasn't far out, was I? Turn it to there and then try and wall. There's no Roger Bleep. Some swines stop the Roger Bleep from working. Isn't that naughty? Oh, dirty dirty squelch control, I'll deal with that. So come back to the power meter, we'll come back to the power because it's been transmitting constantly for a couple of minutes, and let's see if we've got receive. Now I'm going to have to go from my speaker on the wall to the test equipment speaker. I just need to put an earth on for that. So we'll put the signal generator on the correct frequency for channel 20. I'll just show you on the frequency counter where we are on transmit. 2779124. It's just come up at 4 watts exactly. Very, very deaf receive. Now that might be because they've taken something out. You know, where I've taken that crystal filter out, they might have taken some component out there. So I think we need to have a very close look round that area. I mean, there's a part kind of not there. So if I can actually see through the set, hopefully. I can't, you know. I'm going to poke a wire pin or something so I can actually see it. Oh right, yeah, can you see me wire waggling? It says C71. So if we get back our scrap chassis, is there a C71? Yes, there is. Oh right, so we've got a missing part. We've also got, oh no, I couldn't see that. Yeah, C71. So if I recover that off a scrap chassis, we'll use this one. Yes, we've got them new, but I may as well do this. That would have been far cheaper in time to put a new one in. Smarten that up a bit. We're going to have to find out where that Roger Bleep's gone as well. Well, that's not brought our receive back. Just put my earth back on. So we're looking at 300 microvolts there, so plus 30 signal. There is a possibility, of course, the whole thing's so screwed up. I think we're going to do a preliminary retune. But I can't show you the before figures if I do that. I'll just see if there's anything else obvious. Oh, sadly, I can't see anything. I've done all those cracked tracks. RF gain's the wrong way on. Is it dirty control? Oh. That's better. I think we need to change that off a scrap set. It's not, even after cleaning, it's not 100%. I'll not disturb it at full. Right. That's better. Anyway, at least I found that missing capacitor. Unless the Roger Bleep's now back. That could have been that, couldn't it? No. No such luck. It's had its bleep extracted. Perhaps the previous owner got accused of having an Amstrad, and he didn't like that. Even though there's nothing wrong with having a real Amstrad. I'm on the wrong camera, aren't I? Show the SINAD meter. So at the moment, for It's like 0.43, so there's nothing wrong with that. 0.37, 0.95, squelch to full. Put this on the attenuator. So 100 microvolts is what I want. 3, 10, 30, 100. Comes in at 240. So that's okay. And the sensitivity on the squelch is 0.3. I think we're changing the squelch control as well. It's probably been in a very damp environment and probably have been subject to smokers at some point in its life. So meter lamp works. No, the switches don't work, the potentiometers don't work. Well, I don't know that the sockets work either because we've got no PA. So let's go through the receiver. Oh, well, let's look at the meter first. So for S9, oh, perhaps the meter doesn't work. Let's go into transmit. No, meter's not working. Just quickly look at power. I'll fill those figures in. I'll go to that meter as well so you can see what I'm talking about. So there's 5 watts, there's 4 watts. It's 4 watts. Channel 40, 3.95. Channel 1, 4.02. Back to channel 20, current consumption 1.5, 1.503 amps. So our current consumption has come down 50 milliamps and we've gained a watt. So that's what a retune does. Low power, we now have 250 milliwatts. Right, let's attempt a retune on the receiver. Microvolts on the signal generator to be an S9 equivalent. Put enough volume on for a sensible trace. There's our detector. It was absolutely spot on as it was. Just taken the front off and changed the RF gain control. There was a resistor missing. That had been cut off. So we'll go to the SINAD meter. I've done the meter. Needed to open it up and sort out the bearings. So glad about that. So we'll go over to the SINAD meter now and see if anything more can be had. You can usually get a bit better than this out of this chassis, but let's do the front end and drop the squelch off. That was spot on. That was spot on. Might have gained a fraction on that one. Now just do the IFs. So I'm looking at the SINAD meter, I'm looking at the meter on the radio, and I'm looking at the oscilloscope all at the same time. I think we'll start with this one. And not that tool. Struggling to see change on that. Oh, that's better. Very small fraction on that one. A lot on that one. See whether we can get anything on this. I think that was at its optimum position. Okay, so we'll now look at where we are with the sensitivity reading. So now for 12 dB, we've got 0.24. Didn't he do well? 0.21. It's about exactly the same figures, you know, as that 1000 we did the other day. For 20, 0.48. So we'll put 100 microvolts on the signal generator and set the meter for 9. Because that was on full because the meter wasn't working. No doubt someone's tried to adjust that to compensate. You don't get the red light in the back of these like you did in the 1000, probably even the 2000. So that's S9 done. So we can now do the transmit meter. Helps if I plug the mic in. You wouldn't normally have receive except I've bypassed the earth. Right, camera 1. So when we key up, we should be in the centre of the red zone. We're towards the right of the red zone. So that wants to come down a fraction. Centre of the red zone. Good. So I need to find out why there's no Roger Bleep and why PA doesn't work and put a switch where it should be. It's possible that this switch actually just needs taking apart and cleaning. So we've got good transmit, good deviation, good receive. It's just cosmetic, shall we say, inside type of things. I may as well put that through the dishwasher along with the knobs while I've had that off. Right, whilst those parts are in the dishwasher, let's see if we can find what's happened to disable this Roger Bleep, which is clearly what's happened. It's not gone wrong, it's been disabled. So obviously they could have disconnected the wires, couldn't they, to the switch? But there isn't a switch. I'm looking at the Amstrad circuit. No, so that was stupid. Transistor 22, transistor 20, transistor 21. So that's keying it up, I would presume. So we better look around transistor 22. What I've done is also to blow up the layout diagram, and I've highlighted some of the key parts in the Roger bleep. There's transistor 22, 20, 21 and some of the other components. Now because there's no delay, when I key this up there is no delay, so I would think it's this keying up transistor that's been disabled, removed, whatever. So let's have a look. First of all, we'll look at our scrap set and we can see if we can find these key components. So we can see transistor 20 there. We can also see that resistor 108 is missing. We can see transistor 21 on there, and then just under the filter we can see transistor 22. So I think the key thing to look for is transistor 22. Transistor 22 is there. Transistor 20 is there. Transistor 21 is there. Once again, that's not there. So there should be a link there. No, we've not got the link on this set either. When I look closely, I've come back from that wedding. When I look closely, we've got a cut track. And I've looked and I've looked and I've looked. I've come back fresh. Mind you, I've had an hour's kit. And there's a cut track and I've gone and lost it again. I got this transistor voltage chart out from the manual. It only goes as far as transistor 12, and now it's transistor 21 and 22 I wanted to look at. They're obviously too tight to print any more pages. Where's that bit of wire that I had the other minute? This is the second time in my entire life that I've seen a disabled Roger bleep on a Mustang. It wasn't on a 3000. Last time they'd taken a component out and took a capacitor out. So hopefully we're done. We're powered up. Yes! I'm going to turn this to 31. I've come over the tannoy system. Mr. Chip will hear that. He said I won't put the car to bed in case he's getting on the air test. Right, I just need to attend to that. No idea where the other one is. It's that one. Right, I'll go and get one of those from stock. Right, I'll put one wire in, see if we can get the other one in. Not the easiest job in the world. Yeah. we have these in stock. There we go. Front's back out of the dishwasher. Oh, I want to put some lubricant on that one. Okay, so I'll put the speaker back on the lid. These have been through the dishwasher. Put the knobs back on the front. This will probably benefit from a silicone polish. Oh, here comes the next thing, of course. Does the internal speaker work? I think we'll power it up next. Just put that on loosely. Get rid of that bit of mains lead. That can go on the floor. Yay! That looks better, doesn't it? Yes, Mr. Tango. Right. Want some screws. I don't think there's any on here, but there might be the odd one kicking around. Right, microphone. We'll use the standard replacement. I think this could have come with a mic. Let's have a look at what we haven't ticked off now. We've not done the squelch, have we? I've put it back together and not done the squelch. That's been done. Those have been done. And there we are. Let's see. Well, I can't hear anything. So I think we've got a Duff internal speaker. So let's plug in. Yeah. Internal speakers, Duff. That's another thing that's got to be done. So we better just check the squelch because I overlooked that. That might be something else I've got to go back on. It wasn't far out as it was. So connected back to the test gear. Show you the attenuator. Is I've turned the signal generator to standby. Before I do that, I don't know where the delta tune is. I'll put it in the centre. Set squelch. Signal generator back on. Straight in at 0.3. But what's maximum squelch? Well, below me it's 100. It's just where I want it. I didn't adjust it. When I did this video, I did not adjust that, but it's gone right. So, speaker's no good. So we'll do an on-the-air test and we'll do it on the external speaker only at this point. Get a new speaker on that. Well, Nana, Roger. Oh, we're on low power. I think we'll go to 31. There we go. Resurrected Mustang CB3000. Just need to sort the speaker out. Thanks for watching.